Now, if you remember what we were doing was we were studying the reduction of carbonyl group. And the first kind of reduction to alkane we have done. Now the next kind of reduction would be reduction to alcohol. This is what we are going to do. This will be reduction to alcohol. Now from here to here, if you see, one hydride will always come. This hydride comes and attacks this carbon. So a hydrogen comes here with this carbon. O minus is negative charge is developed on oxygen, and that O minus snatches hydrogen from water or any other protic substance present in the system. Fine. So if we have some reagent that will generate hydride ion, then those reagent will reduce this carbonyl group. Not a big deal. Now two such reagent we have studied before. One is lithium aluminium hydride. Lithium aluminium hydride. This is a complex like this. Another one is sodium borohydride. This is a complex like this. Now these two reagents are such, and we have used these two reagents before. So these two are not new for us. Now lithium aluminium hydride is also written as LAH. Lithium aluminium hydride. So generally over the arrow they will write as LAH. So you have to know what this LAH, this is lithium aluminium hydride. For sodium borohydride, generally they'll write it in full NaBH4. Fine. So we have seen these two before, and we know what they do is they generate hydride ion. They generate hydride ion, and one molecule of lithium aluminium hydride will react with 4 of them. Generally what happens is lithium aluminium hydride, this anionic part, this is Li plus, this is AlH4 minus. Now aluminium hydride is this AlH3. So aluminium has 1 2p orbital empty. We know this. With 3p orbital empty, sorry. So in that 3p orbital, if a hydride is there in the system, it forms a complex. Aluminium hydride plus one more hydride gives you AlH4 minus. Now this happens when this hydride put its electron into the empty 3p orbital of aluminium. So this hydride is stabilized. Now this AlH4 is much more stable than NaH. In this case, there is hydride and this is sodium. This hydride is not involved in any kind of complex. But this is a complex. So this is a stabilized hydride. So the reaction with lithium aluminium hydride and sodium borohydride, same goes with boron. Boron has a 2p orbital empty, and in that 2p orbital, this BH3 plus hydride will give BH4 minus. So in this case, hydride put its electron into the empty 2p orbital of boron. In this case, hydride put its electron into the empty 3p orbital of aluminium. So in this case, in these two complexes, the hydrides are in form of complex. In NaH, sodium hydride is not in the form of complex. So the reaction is occurs in a controlled fashion. This complex releases hydride slowly, but in this case, there is no stabilization of hydride. So reaction is more violent. So generally, we don't take sodium hydride directly. We take hydrides in the form of complex like this. So what happens is, they will release, because aluminum is electropositive element. So this aluminum that will gain, aluminum is making 3 bonds with hydrogen like this. When it makes the 4th bond, aluminum is the one that is having negative charge. So this is not stable. Negative charge is not stable on electropositive element. Aluminum is an electropositive element. So it will try and lose one hydrogen atom in the form of hydride. So this hydride goes and attack this carbon. So what happens is, when a hydride comes and attacks this carbon, a negative charge develops on this oxygen. Fine. So this aluminium, after releasing hydride, this AlH4 minus has become AlH3. Now the orbital in which the hydride used to put its electron is empty once again. So now the oxygen can take advantage and put its electron into the orbital of aluminum. Then aluminum will again develop a negative charge. When it again develops a negative charge, one hydride will again be released, and that hydride can go and attack another unreacted carbonyl group. So just to give you a little bit of idea as to what's happening. When oxygen puts its electron into the orbital of aluminum, this is what happens. Aluminum generates a negative charge. So now because aluminum again has developed a negative charge, so again it has a tendency to lose one hydride. So other unreacted carbonyl group can again go for the reaction, and from here one hydrogen will come out. So now here two hydrogens will be left. And that hydride comes and attacks this. Like this. Now aluminum becomes neutral. Again this oxygen will put its electron into the orbital of aluminum. So aluminum will again develop a negative charge. Now again it will lose one more hydride. Likewise one lithium aluminum hydride is going to reduce 4 molecules of this carbonyl compound. So the chain will keep on moving. I'm not writing the whole thing, but that's how it happens. For us, what do we have to remember? We have to remember that aluminum hydride and lithium aluminum hydride and sodium borohydride are hydride generators. They generate hydride in a controlled fashion. Now when they generate hydride, the first step is this reduction. And next at the end, when you protonate it, you will get this alcohol. No trouble? Fine. So that's what is the reduction with lithium aluminum hydride and sodium borohydride. Now in this two kind of reduction, the number of carbon did not increase and you get the alcohol. Fine. So this is one kind of reduction to get the alcohol. The second kind of reduction to get the alcohol would be reaction with Grignard reagent. If you take a carbonyl compound like this and you take RMgX, fine. So this reaction we have studied in great depth when we studied the topic Grignard reagent. So there shouldn't be any problem to identify what the product is going to be. This R minus is going to attack the C double bond O. That's what C minus does, isn't it? So you are going to have this. And in the next step, after the reaction with Grignard reagent is complete, you will protonate it and you will have a protonated neutral alcohol. So in this case, the degree is going to increase. If you reduce this with lithium aluminum hydride, if you carry out reaction with LaH, you are going to have a 2-degree alcohol. And if you are carrying out it with Grignard reagent, then the whole structure of the substrate will change and you are going to have a 3-degree alcohol. Whatever it is, you know what will happen. If you take lithium aluminum hydride, hydride is going to come and attack C double bond O. If you are taking a R minus, that R minus is going to come and attack C double bond O. This we have done before. There's nothing new in this. So that completes this chapter. That completes the reduction of carbonyl group. So carbonyl group can be reduced into can have two kinds of reduction. One will be the reduction to alkanes, which is done by Wolff-Kishner reduction and Clemenson reduction. The other is reduction to alcohol. And that can be done by lithium aluminum hydride, sodium borohydride, or by any complex that has R minus. And one of them, and the important one of them, is Grignard reagent. Fine. Thank you.